Hello, good evening all.
Good evening, sir.
So we are today at the last session. So if you have any doubts regarding the course, please ask today. So let's get started with today's session. So we are at the final session, right? So I welcome you all to this live session for a numerical methods for engineers. This is a 12th and a final session for problem solving. So in the last, I have been taking this problem solving session since July when the course is started, and I am Rigved Samant. Welcome you all to this session. So, for last 3 weeks, we are working on ordinary differential equations, right? Ordinary differential equations. Let me just check the. Okay. Recording is on. Okay. So it's good. So in ordinary differential equations, we started with the initial value initial IVP, initial value problems. So initial value problems means order differential equation. What is the ordinary differential equation? So let's say you have a function. If this is a t, this is a y. Better say we'll call it a y of t. So ordinary differential equation is the first order slope. So this slope of this line at this point can be called as dy by dt, right? So using the slope, using the equation of the slope, we are trying to find the function parameters at some point. So in initial value problem, you had given the value at t is equal to 0, and with t is equal to 0, you are, and equation of the slope, you are trying to find the y of t at some t is equal to some tn, some value, right? So that what we were doing, and that we solved using Euler's method, Heun's method, there is RK2 and RK4 method. We also saw what is the order of accuracy of it in the last class, how to calculate order of accuracy. Then we also saw how to improve the accuracy of the improve the solution result. So we do some extrapolation with the same method, and all those techniques we saw. So this is the initial value problem. So there is another class of ordinary differential equation which is called as a boundary value problem. So boundary value problem means you will be given some two conditions, all right? Let those two conditions. So here only you have given the initial condition. There might be a two conditions in between. Let's say I give you t at some 2, and let's say t at some 10. I give you the y value, y at 10 and y at 2. Using these two, I ask you to find the value in between 2 and 10. Somewhere y is equal to 4 is equal to what? And I have only given you the differential equation, that is a slope. Or if it's a higher order, it won't be a slope. But I'm just telling you in the this what we say diagram. That's why I'm saying slope. And using that, you are trying to find the value in between. So it is a bounded problem, and you have to meet it two conditions. All right. So because of that, the method of solving it becomes very different than how you are solving it using the initial value problem. So we will look into it how to solve these boundary value problems uh, with the help of numericals. So first question is, consider the problem of modeling a heat sink using the cooling of a computer CPU. Model of a heat conduction in a single fin of the heat sink results in the following ordinary differential equation boundary value problem. So why it is a boundary value problem? He has given you a value at two conditions. T at 0, that is he has given you initial condition, and T at 2, that is he has given you some condition at the end. Alright. So I had forgot to give you the this thing. There is a diagram. So diagram goes as this. So this is t is equal to 0. This is t is equal to 2. Okay. You have given capital T here, that is 0 temperature, and capital T here at the end, that is that is a T left. This T is equal to T naught is equal to T left, right? And T left is 300. So this is T is equal to 300. And here T2 is equal to T right? So here it is given 25. And what it asks you, find the temperature at x is equal to 2. So somewhere in between. So this should be T all, right? Oh, it's a heat sink, right? Sorry, my bad. So this should be x only. This is not temperature, this is a diffusion, right? So it would be in the terms of x, not a time. So this is 2. So it asking you to find out what is the value at this x is equal to 1. Okay, you have given two conditions and you have given this ordinary differential equation. Now if you see in the last class what we were solving those equations, can you see any dissimilarity with this one in the last two sessions? The order of ordinary differential equation is higher. Alright, so those Heun's method, RK method and Euler method, they are applicable for a first order ordinary differential equation. So for a second order, we can still use that. We will see into the next question. But there is a one other way by which we can solve it using a definition of the center difference, or also called as a finite difference method. So let's say it has said h is equal to 0.2. So let's say h is equal to 0.2 and there are from 0 to 2. So how many intervals would be there? Can anybody tell me? Step size is h is equal to 0.2 and we are going from a is equal to 0 to b is equal to 2. What would be n? N is equal to, yes, b minus a divided by h, that is 10 minus 0 divided by 0.2 is equal to 10. So let us say we divide this the fin in 10 intervals. Let's say 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 1, 2, 3, 4, 5, 6. Okay, so we have a 10 intervals, right? So if we start numbering here, let's say we will start from 1 here. So if its temperature at is a T1, at this point it is T2, T3, T4, T5, T6, T7, T8, T9, T10, T11. This is dimensions. Okay, T1 means T at x is equal to 1, T2 means T at x is equal to 2. I hope you understand. Okay, so this is a T at x is equal to 11. Okay, so this is what I mean. So if we at a start, what we have, what is T1 that we have, this T1 value we have, and this T11 value we have. What is the T11 value? 25. T1 value is 300. Now it has asked you to find a x is equal to 1, right? So when the x is equal to 1, so this is what will the h size? H is equal to 0.2. So this is 0, 0.2, 0.4, 0.6, 0.8, 1. So you want to find what is T6 is equal to what? That what you want to find. Okay. Now, if you see this point, the temperature at this point would be dependent on this point and this point. Are you all agree? Hello? Similarly, temperature at this point would be dependent on this value and this value.
Yes.
For this value and this value.
Yes, interrelated.
Yeah, so we can do a approximation to this ordinary differential equation. So what that central difference finite difference approximation is such that this d square t by dx square. So these are I is equal, something's I, right? For I, if you substitute, then we can write it as ti plus 1 minus 2ti plus ti minus 1 divided by what is dx, that is this h. Because this is a x, we can call it a delta x as well. So this is a delta x square. Delta x is nothing but h here. Okay. All you guys agree with this?
Yes.
Okay. So with this formula, with this approximation, we can convert this left hand side to this value, and then if you see, this equation becomes an algebraic equation, right? Because you have a ti value, and these values you can keep it as an unknown, and then you can write an equation for each and every point, this point, this point, this point, this point. Then you will have a simultaneous linear equations with n equations in n unknowns. So we'll see how it goes. So therefore ODE becomes ti plus 1 minus 2ti plus ti minus 1 divided by delta x square is equal to what? Alpha ti minus t alpha. Now you know the value of alpha, right? Ti would be dependent on what the I value you are working on, and Ta is also given to you, right? Ta, this is Ta, okay? Ta, that is ambient temperature. So you write into this. You know the delta x square value as well, that is h. H is 0.2. So we can further simplify this as ti plus 1 minus 2ti plus ti minus 1 divided by delta x square means 0.02 0.2 square into what is the alpha value? Alpha value is 20 Ti minus Ta. Ta is 25. Correct? So now you simplify this. So this is what? This would become 0.04. So 1 divided by 0.04, it would become 25, right? 25 Ti plus 1 minus 2 divided by 0.04, so 25 into 2, that is 50 Ti plus 25 Ti minus 1 is equal to 20 Ti minus 500. Cool. So we can take this Ti into the left hand side. So it would further simplify as 25 Ti plus 1 minus this 50 minus this 20, 70 Ti plus 25 Ti minus 1 is equal to minus 500. What is this I plus 1 and I minus 1? I hope you understand. Considering a point, let's say if you are at this second point, Ti minus 1 would be this, and Ti plus 1 would be this, and this would be Ti. That's what we are talking about. So this is T1 is a Ti minus 1, T3 is a Ti plus 1. So this equation you get. But what you want the value at T6. What you can do is, you can write, what we can do, can anybody suggest? You have this equation, you only have values at starting and you have only value at end.
You can write it in the matrix form.
Yeah, you can write it in the matrix form. So how we will get that? We'll start with I is equal to 0, but for I is equal to 1, but if you see that central difference formula is only valid from 2 to 10. For 11 and 1, that central difference formula is not applicable or need not required because the equation is already known. Because if you consider T1, Ti minus 1 would be T0 somewhere, and that is ambient temperature. So we don't want to consider that because you already know the value. So if you start, T1 is equal to, what's the T1 value? 300. Okay. Now I is equal to 2. What it will imply? 25 Ti plus 1, that is 2, minus 70 Ti, that is, sorry, I plus 1, 3 here, 3, this is 2, plus 25 Ti minus 1, this is T1, is equal to minus 500. Similarly, if I is equal to 3, what will happen? 25 T4 minus 70 T3 plus 25 T2 is equal to minus 500. I is equal to 4, 25 T5 minus 70 T4 plus 25 T3 is equal to minus 500. So you get it, right? So as you go along till I is equal to 10, you will get 25 T11 minus 70 T10 plus 25 T9 is equal to minus 500. So now you can write it in the matrix form. Matrix form, how it would be? What will the first row? What will the first element?
1.
1, right? So That's how it is. I forgot to write one more equation. T11 would be, so this is equation 1, so okay, and T11 is equal to 25 or 20, 25. This is equation 11. Okay, so therefore your equation, you have to just write the coefficients here. So first would be 1 0 0 0 till 0. Second would be 25 minus 70. So 25 minus 70, 25. The equation coefficient of T1, T2, T3. So 25 minus 70, 25. 0, 0. What will be here? First here, third row, first element would be 0, right? Because there is no T1 in that. Then 25 minus 70, 25. T2, T3, T4. 25 minus 70, 25. Then 0, 0, 25 minus 70, 25, 0. So what kind of a matrix it is forming? So at the end here it would be 1 and all 0 0 till 0. This equation, this row would be 25 minus 70, 25, 0 0, so on. So write in a bit 0 0 0 1. So what kind of a matrix it is? So what would be here? T1, T2, T3, so on till T11. And right hand side would be, what would right hand side? All would be minus 500. Sorry, not all. The first and the last one would be, because the first equation is T1 is equal to 300, right? So that is 1 into T1, that is T1 is equal to 300, and the last is 1 into T11, that is 25. The rest of it would be minus 500. Okay. So this is again the AX is equal to B format. Okay. So what is the nature of A? We had seen this in first module, I guess, right? Can anybody guess? This is a special case of matrix. So how you guys will solve this one? How you want to find a value of T6? How you will find it? Can anybody tell me? Because this thing has already been taught and you guys have submitted the assignment on this. So in the first module we had studied Gauss elimination, Gauss Seidel, backside. Yes, exactly. So those method we can use, because this is a simultaneous linear equations, n equations in n unknowns, 11 equations in 11 unknowns, right? So that's what it is. Now rather than using a back substitution, in this case I would use something else rather than using a back substitution. Back substitution will also give you the results, but there is a one more technique that we studied which will give you result much more faster and which will not have a problem of that what we call ill conditionality. So this is a tridiagonal matrix, special case of tridiagonal matrix. These all are 0, these all are upper 0, lower 0 and 3 rows, right? So this is a tridiagonal matrix. So there is tridiagonal matrix algorithm that we saw, right, at the last in the module 1, tridiagonal matrix algorithm. So that one will deploy TDMA, tridiagonal matrix algorithm, also known as a Thomas algorithm, to get the values. So you will, after using that, you will get all values T1, T2, so T3, T4, T5, T6. So whatever value you require, you can get from this. So this is how you solve a boundary value problem using a finite difference. Okay. Any doubts here? No, right? So we'll move forward. So the next one is, for the following mass spring damper system, find the value of x is x 0.5 using a Euler's explicit method. Sorry. Euler's explicit method. And what is the ordinary differential equation? This is the ordinary differential equation that you have. Can we solve this? Can you tell me, is this a boundary value problem or not?
Boundary values only.
Why?
Because initial condition, final condition is same.
Where is the final condition? Think about it. Okay, so here x of 0, and this is also given to you. Initial condition is given to you, and slope at initial value is given to you. Yes, Newman boundary value problem. This is a Dirichlet boundary value. This is a Dirichlet boundary. So how to solve this one? What is the problem with using Euler's method as it is? Euler's method is only applicable for a ODE of the first order. Now this is the ODE of the second order, right? So how we can use that is, we can do some substitution. So what substitution we can do? We can introduce one dummy variable. So dummy variable z we can introduce. So what the z can be? So let's say let z is equal to dx by dt, or better way we'll write
In place of z, you can use y.
Huh?
Can you use y?
With
Dummy
y.
variable.
Okay, with y it will be so we are using a dummy variable, right? With y also you can solve, but z is like a dummy variable, so till now we have been using t x y. We can use y, we can use y, no worries. Dx by dt is equal to y, no worries in this. So what will equation become? So what does this mean? Dx by dt at t is equal to 0 is equal to what? Y of 0, and that is equal to 0. It is given here, right? Correct, right? Also d square x by dt square, that would be y square. So y is a dummy variable here. Therefore, what will what is will the ODE become? D square dt square is like, so sorry, this is not y square, this would be dy by dt. Sorry, this is not a square, right? If it would have been a square, then it could have been a y square. This is a differential with dt, so dy by dt. So therefore ODE becomes dy by dt plus 3 into dx by dt is y, so y cube minus 2.4x is equal to 0, right? This one we can use. So now it is ordinary differential equation of the first order, but still it is not capturing the relationship of the dummy variable with the actual variable, right? So we have to consider a system of equation. So first we will write it in the terms of dy by dt is equal to what? 2.4x minus 3y cube. So this is one of the equation, and then what other equation you have? And dx by dt is equal to y. So this is the one equation, this is the second equation. Okay, what are the variables that are used in this one? So this is a function of t, x and y. This is also function of t, x and y, and there are two different functions, so we'll name it f1 and f2. f1 txy, f2 txy. So what is f1 txy is dy by dt, so I'll not write it again. So you understood, right? This is f2 txy, f1 txy. So these are two functions, system of ODE we can call it, system of ODE. So now you have two different ordinary differential equations, each capturing relationship with each other. So now what you have to do is you have to use Euler's method simultaneously. So first you will use Euler's method on this thing, and then you will take that value and then put it into this. So what is Euler's method? Using Euler's method, if you wanted to extrapolate xi plus 1 for this, what it would be? So in Euler's method, what we do is we try to find out what is the value of xi plus 1, right? From the xi. So xi plus 1 is equal to xi plus h into f of what? f1 or f2? X is in the f1, right? So f1 t I x I y I, and y of I plus 1, that will be captured by this equation. This is yi plus h into f2 ti xi yi. Understood? Are you understanding what we have done here? Now what we have to do, we have to find x is equal to x at t is equal to 0.5 and h is 0.25. So it is telling you go from 0 to 0.5 with 0.25. So there would be two intervals, so you have to apply this thing twice. right? So I is equal to 0. So first we'll write t0 is equal to 0. t0 is equal to 0. x0, that is x of 0 is what? X of 0 is 2 and y of 0 is 0 is 0, right? So the equation becomes, this equation becomes, because I is equal to 0, x1 is equal to x0 plus h into f1 of t0 x0 y0, right? What is x0? x0 is 2, h is 0.25 into f1 of t0 x0 y0. Now if you see f1 is just y, so you only have to consider 2 into plus 0.25 into, this is only y, right? Function is y only, so this is into 0, so implies x of 1 is 2. Understood? So what is x of 1? If you see it from here, x of 0 is x at t x of 0, x1 is equal to x0 plus h, that is 0.2 x of 0.25. So this has to be better way. t1 is t0 plus h, that is 0.25, therefore x of 0.25 is x1, and t2 is t1 plus h, that is 0.5, therefore x2 is equal to x of 0.5. So we have to find what is x of 0.5. But if you want to now if somebody can say why to calculate y value, I can directly go for a value of from, I only want to find out using this equation, and I will use this equation and I will directly go from here to here. But you cannot go, because to find x of 2 you will require a y of 1. So the equation will become x of 2 is equal to x1 plus h into f1 of t1 x1 y1. You have a t1, you have a x1, but you still require a y1. So first you have to calculate y1. So y1 will be from this equation, y1 is equal to y0 plus h of f2 of t0 x0 y0. So this is y0 is what? Y of 0 is 0, right? Y of 0 is 0. H is 0.25 into f2 of 0 to 0. What is f2? f2 is this equation. In that put x is equal to x0, y is equal to y0. So x is 2, y is equal to 0. So 0.25 into 2.4 into x, 2.4 into 2 in minus 3 into 0 cube, so I will not write that. So 0.25 into 4.8, so 4.8 divided by 4, it is 12 4s are 14, 1.2. So you got x1, you got y1. Now using this x1, y1, you can calculate x2. How you will calculate x of I of 1? If you consider I of 1, it will, the equation, this equation will become x of 2 is equal to x1 plus h into f of 1 f1 of t1 x1 y1, right? x1 is 2, h is 0.25 into f1 of what is t1 0.25, what is x1 2, y1 1.2, 2 plus 0.25. What is f1? f1 is just a y, function of f1 is just a y, so y is into 1.2. So 2 plus 0.25 into 1.2, is it 1.2 divided by 4, that is 0.3, so 2.3. So this is nothing but that is x of 0.5 is equal to 2.3. Now you understood how to go about when you have a ordinary differential equation of a higher order and you want to use a this thing, it's Euler's method. Now this was facilitated because we knew a boundary condition, the initial condition, and also the slope at that condition. Okay, so because of that we were able to solve this. If you had not given this value, what is the slope at the start, then this solution would have been difficult. So because the order is 2, we at least require 2 unknowns, 2 what we say unknown values at the start. So what we do is we take some dummy variable, we write the equation in the system of equations. We from second order equation we write into 2 first order equation, a pair of what we say dependent first order equation on each other, and then we solve it using a basic Euler's method only. Just the catch would be both of the equations are a function of t, x and y, and both the equations should be numbered differently, f1 and f2, and then you can easily proceed with the procedure of Euler's method. Now this logic can be extended to Heun's method. Are you agree? Do you agree with this? So what is a Heun's method? Heun's method is in our Heun's method we take the slope, the average of the k1 k2 value and multiply it with the step size. So basically slope at the start, slope at the end, and the average of it, right? K1 k2. So we can obviously we can extend it. It would be bit tricky. So we'll just go solve that also, and then we'll get an idea how it will it is actually improving the results already. So here we will directly go by the single application. So h is equal to 0.5. On your own you can try using a 2 applications. So in the last problem we did a 2 applications of Euler's method, right? Now I am doing that is 0 to 0.5. So any doubts in this previous question?
So you not calculated y2?
Y2 you can calculate, but the question asks us to solve for x is equal to 0.5, right? If you want to calculate, you just can easily calculate. What would be the y2 equation? Y2 would be y1 plus h into f1 of t1 x1 y1. So y1 is what? 1.2, h is 0.25, and f1 is, this is 0.25 to 1.2, and the equation is what? 2.4x minus 3y. So 2.4x is 2 plus 3 into y cube, 1.2. Whatever answer you get, that is your y2.
Okay, sir.
So For a following mass space damper system, find the value of x at 0.5 using a Heun's method. Take h is equal to 0.5. So we are using a single application. So now first what we'll do, again we'll write that equation into the this format. So take let dx by dt is equal to y implies d square x by dt square is equal to dy by dt, and dx by dt at t is equal to 0 is equal to y of 0 is equal to 0, right? X of 0, that is x0 is equal to 2, this is y0, t0 is equal to 0, right? So now what we are going to do, you first write in function f1, function f2, and then we'll proceed with the Heun's method, and then we'll see how Heun's method will have to tweak a little. So what is the first equation? Because of this substitution, the ODE becomes dy by dt plus 3y cubed minus 2.4x is equal to 0. Therefore dy by dt is equal to 2.4x minus 3y cubed, right? So this is f2 of t1 ti xi yi, or sorry txy, and the second equation is dx by dt is equal to y, that is f1 of txy. So equation 1, equation 2. So what is the Heun's method for f of t comma x? So for f of t comma x, some function, what is a Heun's method formula? So xi plus 1 would be x0 plus, sorry, xi plus h by 2 into k1 plus k2, correct? And what would be k1? K1 would be f of t I y xi, ti xi, and k2 would be f of ti plus h, comma, here it would be k1 plus h, right? xi plus k1 into h, right? We are writing hk1, so just to keep it a continuity, xi plus hk1, right? So for xi one equation, you have to write these two equation and solve. Now what will happen is, because there is this equation first, dx plus dt, for this one there would be two k1s, for f1 there would be two k1s, that is k1 y and k2y, and for this there would be two k1 k's, k1 sorry, this is in the terms of x, right? So it will have k1x, k2x, and this is k1y and k2y. So we'll see how it becomes. So for a first equation, what would be right? So what is the first equation in these terms of this equation? Dx by dt. We are trying to find a value for xi plus 1. So xi plus 1 is equal to x0 using a Heun's method, right? Heun's method. Xi plus 1 is x0 plus h by 2 k1 k2, but these are for a function of x, right? So for we have superscript x, k1x, k2x. What is k1x? F of ti xi. Am I correct or wrong? If you have been listening from whatever I have been talking since the start, you should have been not okay with what I have written. F1 of, in the bracket, what it would be? So there are three arguments for F1, right? So F1 of ti xi yi. Correct? Now k2x, now you see it would be, k2 would be dependent on f2 or f1. We are still in this function, we are still using dx by dt, so still we are working with the f1. So again it would be f1. For k2 it would be f1. What its first equation, the independent variable is just ti plus h. So ti, sorry, dependent, ti plus h, and then these two dependent variables for this. First is xi, right? So xi is, and then yi. So xi into h of k1x, comma yi plus h into k1y. So here to find out k2x, you require k1x as well as k1y. Always remember. Okay, what is a k1y? What is a point for, because for y the point would be different, right? So that's what it is describing. Similarly, this is a set for first equation. Now for yi plus 1, yi plus 1 is y0 plus h by 2 k1x, sorry, k1y plus k2y, right? What is k1y would be here. Now we are doing for this second equation. So it would be f2 of ti xi yi. K2y would be f2 of ti plus h xi plus h into k1x yi plus h into k1y. Now if you see, this bracket and this bracket is same, this will always be same. If you see a previous example, this bracket was same, right? So this inside bracket would be same. So what it is saying, the point that you are working on are same, but the function that you are solving it for. So there are 3 points, 1, 2, 3, and so right now there are 3 different variables. I am just telling you there are 3 different points, and these are, so this you have to have a 3 different lines, right? I'm just telling you. So there are 2 functions, let's say. We are saying it from one angle, so that's why it's looking like this. So we have 3 different points for this is f1, and 3 different points for F2. Okay, so this is what I am talking about. So the inside bracket would be similar, but the function that you will be using will be dependent on what function that you are solving it for. So f1 f2 will decided from the what function you are solving it for. Now what will the sequence of solving this equation? Now you cannot go directly like how it is, right? First you will find out what is this value, because you have all the conditions, right? You will have t0, x0, y0, but to find out k2x you require a k1y. So second you will find what is a k1y, because you again have t0, x0, y0. Now because you have these two, then you will find out this 3. Because you have these two values, you can now find out this one. Now again, as sir was asking y1, then you can also find out this one, because by that time you will be having k1 and k2x. You can find out this one and then this one, but as of the question you just want to stick to this. So we will start with I is equal to 0, and let's see I is equal to 0, then what will it change? X1 is equal to x0, so this should have been xi and yi, sorry, talking about i's, right? So x0 plus h by 2 into k1x plus k2x. Therefore first we are trying to find a k1x. K1x is f1 of t0, x0, y0. We all have three values, x0, t0 0, x0 2, y0 0. So this is 0 to 0, right? What is a f1? F1 is this, only y. So k1x is equal to y, so that is 0. Okay, now you cannot directly find out k2x because you require k1y for this. So second step would be, I will find k1y, that is f2 of t0, x0, y0, that is 0 to 0. So what is f2? 2.4x minus 3y cube. So 2.4 into x, that is 2, minus 3 into 0 cube. So this is 0, this is 4.8, k2, k1y, sorry, k1y. Now you have a k1x, you have k1y. Now you can find out what is k2x. Therefore k2x is equal to f1 of, at I is equal to 0, so t0 plus h, comma, x0 plus h into k1x, comma, y0 into y0 plus h into k1y. Okay. What is t0 plus h? 0 plus 0.25, right? No, h is 0.5 here. So this is 0.5. x0 is 0 plus h is 0.5 into k1x. k1x is again 0. y0 is, so x0 was 2 actually. x0 was 2. x0 is started as a 2, right? x0 is 2. y0 is 0, h is 0.5 into k1y, that is 4.8. So that is f1 of 0.5, this is 0, comma 2, 0.5 into 4.8, so 4.8 divided by 2, that is 2.4. So you will find out a value of, so this is f2, right? K2x is, sorry, K2 is x1, sorry, it's correct. So f1 is what? This one. So what is the value of y? This is t, this is x, this is y. So this is basically 2.4. This is K2x. You now have a K1x. Now you have a K2x. Using this expression, you can find a value of x1. Therefore, x1 is equal to x0 plus h by 2, that is 0.5 by 2. x0 is what? x0 is 2, right? x0 is 2 plus h by 2 is 0.25 into k1x plus k2x. k1x is 0, k2x is 2.4. So 2.4 divided by 4 is 0.6. 0.6 plus 2, 2 plus 0.6, that is 2.6. And that is nothing but x of 0.5, right? Because t0 is equal to 0, t1 is equal to t0 plus h, it is 0 plus 0.5, that is 0.5, implies x1 is equal to x of 0.5. Any problem? You can further go ahead and calculate y1 as well. So how to calculate y1? Therefore, for y1 you will require k2y. So first, we have already calculated k1y, k1x and k2x. You also calculate k2y first. You will get the value and then you will substitute it here. Do we have any doubts till now? Do you want me to repeat this? Or is you guys have understood the basic principle, basic concept or basic logic of it?
Understood, sir.
Yeah. So now you can calculate y, this thing, k2y. So k2y will be, what will be k2y? So we already got a final answer. I am just completing it. What is k2y? f2 of this only, this point only, 0.5 to 2.4. So f2 is what? This second equation, this equation, 2.4 minus 3y cube. So 2.4x, so this is x, this is y. 2.4x minus 3 into 2.4 cube. Find this value. This is 4.8 to 3 into, so it will be negative. What is the value? Can anybody tell me the value? Okay, minus 36.672. Okay. So therefore, if you put I is equal to 0 here, y1 is equal to y0 plus h by 2 into k1y plus k2y. y, right? y0 is 0, that is given. This is h by 2, that is 0.25. k1y is 4.8 plus k2y is minus 36.672. So whatever the answer you get, that is your y1. I hope you understood the logic of solving this. If you have any doubts, you can still go back again to this equation. Cool. So we will not solve this, we will just discuss how to get to the final answer. So again, this is again a similar problem to the first one. What we have to do here, the deflection y in the simply supported beam with the uniform load Q and tensile axial load T is given by this formula, right, where x, t, e, I is these functions. So deflection of beam y, so that, and this whatever the intermediate whatever the constant values that are also given to you. So what, again there is the same thing, you also don't require what is a mathematical, what is actual engineering problem is behind you. What you want is a dependent variable, and we are trying to find out its what we say, we have ordered differential equation of that dependent variable, and from that we are trying to find out the value at certain point for the dependent variable. Here you have been given these things. There are the step size of h is 0.25, but you will require these things, right? Initial conditions, do you require in this problem, whatever problem we are discussing right now? How you will solve using finite difference? In finite difference, do we require an initial condition? Check your first problem. We actually not use the initial condition. We simplified this d square y dx square as yi plus 1 minus 2 I plus yi minus 1 divided by delta x square. So same thing you will do here. There it was x divided by t, now it is y divided by x. So for y we are finding out, so this is y plus 1 y. Here you want to find the step size of h is equal to 0.25, and to find the deflection of x is equal to 0.5, 50 inch. Where are the values? Yes, I forgot to give you those two values. Let me just check, okay? Can you guys solve this? Can anybody give me comment? how to go about this one. You can compare it with the question number 1. In question number 1, what we had to do, Ghanasham, can you speak up? Like what we can do here? Nobody. You have exam in when's the exam?
28th of this month.
20th of this month. Okay. So guys prepared. Today is 17th, right? 3 days.
No, on 28th of next week.
28th.
20.
Oh. Okay, what we'll do, I am there on the Google forum. I will not tell you right now because you guys are not even having any conversation with this. So what we'll do, I will put it in my notebook. You try to solve this. How you will solve this? If you have any doubts, believe me, you have exam. If you have any doubts, you please put it on the Google forum. I'll get back to you. Take the photo of this and then we'll discuss about this, because if everything I'm telling you, then you guys are not putting any efforts, because whatever problems today I discuss are actually the same problems, I guess, more or less, in the assignment. The notations and the equation, these things are same, different. So I'll just leave it to you guys how you will solve this with. If you have any doubts, then please, I am there till your exam. It's not like today my last session was I will not respond to your queries. Feel free to post it onto the Google forum. If you have any doubt related to previous question, then we can discuss, or the previous modules. Otherwise, we will wind up for today.
Summarize that one, sir. First to third.
Sorry, first to third. So what was the first question? In the first question, we had given a boundary value problem. So what is a boundary value problem? We have this this thing, order differential equation with two endpoints. So two initial condition and to initial condition or a final condition. It might not be initial condition. It can be any two values of the function that is given to you, and from that you want to find out the value in between those interval. Now if you sometimes what happens is the function is such that here for these initial these boundary value problems we got the solution, but there are some cases, so you need not worry about it. I am just telling you some extra stuff. So there are some cases that the solution might not be possible with those boundary conditions. So there are those things. So here for this one, at the start from the 2 weeks we are solving order differential equation for an initial value problem. So initial value problem we solve it using Euler's method, Heun's method. In that we had a initial value at x is equal to 0, and from that we were solving. But those solutions are possible only for equations with the first order. Now you have given an equation in the second order with the order for this thing, boundary value. So in this case, you can, rather than going for those method, you can leverage the finite difference theorem and write down a simultaneous linear equations of n equations in n unknowns with taking care of this interval business. So you have to characterize this. So in this case also, in the third case also, you you want to find out that x is equal to 50. So you will go from x is equal to 0, x is equal to 1, x is equal to 2, right? And then you have to decide what will be the value of h. So that you have to take care of, and from that you will get the simultaneous linear equations. And when you solve, once you get the simultaneous linear equations, you can solve it using any of the linear equation techniques that are Gauss-Seidel, Gauss-Jordan, or for this one, because it's a tridiagonal matrix, we are using a TDMA. Now, if you have a Dirichlet boundary condition, in this case, Dirichlet means there is a boundary value. If you are given two boundary values, one is the boundary value and the slope at that boundary value, slope at that boundary and the value at that boundary, that is given to you. In this case, you can use a Euler's methods or a Heun's method that we used using in the initial value problem. Because there is a two order, we require the slope. Without a slope, you cannot solve the second order equation. Okay, so Euler's explicit method, this is against the extension of what we did in the previous classes. We saw how to incorporate an extra variable into the Euler's method. Now, because it is a second order equation and the Heun's methods, Euler's method, RK method is for a first order, we convert the second order equation into the two first order equation and write the system of ordinary differential equation. First we convert it to system ordinary differential equation, then we solve it using a Euler whatever method you are trying to solve. Accordingly, we will change the points. So these points will change. Similarly for Heun's method. In Heun's method, we have to take care of this K1, K2 business. Now this idea can also be extended to RK4 method as well. So that we have not discussed in the class, and that is not also there in your tutorial. That's why I have not discussed. But keep in mind that this can also be extended to the RK4 method. It's not like RK4 method will not be useful. RK4 method can be also be used. Then you have to do K1, K2, K3, K4 for both of them, for this one and for that one. So there would be total 8 Ks, and then there would be some relation of each other, and then you have to solve. So that would be very tedious, but your solution would be more accurate. So this is all. Is there anything else you want to discuss about this? Naveen sir?
Nothing.
You have any doubts or something?
Actually, we need step-by-step solution of assignment, sir. But
that actually, that's not in my hand. That is the hand in actually. I have told them to provide you. I hope they will give you.
thank you.
Thank you. We'll see. All the best for the exam. Good night.
Thank you.
If you have any doubts, still post in the Google forum. Okay.
Okay.
Thank you. Ganesham, do you have any doubt? Something? Try to solve the last equation. Then
Okay, sir.
Thank you.